this slide, it shows a little bit talking about what's you know, the protocols that are laid down in the BAT. I mean, obviously, air scrubbing is a fairly flexible technology, so you know, it's almost a case of it can deliver what we throw at the problem. I mean, today we also have air cleaning systems that reduce ammonia from composting, where we're talking very high levels of ammonia ppm. 3,000 ppm is pretty common, but you know, it's a matter of balance. How much reduction do we need to make for what would be regarded as normal production? So I've listed here a couple of specifications about the system. I mean, on a biological system, in this case, based under this certificate, the packing material runs at around 90 centimeters deep to get that level of contact. The pH for a biological scrubber tends to sit around 6.5 to 7.2. The backdrop on all scrubbers, we have to allow for a maximum of 65 pascals, but typically they would run a lot lower than that, probably around 20 to 25. In terms of reduction, I've listed what we would regard as standard for this certificate, but then sort of demonstrating that you can upgrade by increasing the throughput, or reducing the throughput of air across the packing material, allowing more contact time, which would mean further reductions in ammonia or odour. The point about that, of course, is that would require a bigger scrubber that comes at a slightly greater expense. On the right, I've done the same very much for chemical. The pH range for a chemical scrubber is between 3 to 4 pH, so on the acid side, but nothing stronger than a Coca-Cola or an apple, so not terribly acidic, just enough to do the binding. And as you can see here, the higher level chemical scrubber runs at 90% ammonia reduction. The odour not as high as a biological process, because that's better at reducing odour. So chemical tends to be delivering ammonia reduction. It produces, as part of that process, less wastewater than the biological, which is more focused on reducing odour reductions.